So as I mentioned before, sometimes just disassembling the code and following the jumps would not be enough. And a very simple example of such case would be either call or jump through register, or in combination of instructions like this, like pushing the register on the stack and then a return instruction to return to that address. These obfuscations were already existing in the code. That would be one reason why you would want to have an emulator. Another reason is that data section of the malware could contain some encrypted data. It could be strings, it could be some data structures, but those data structures might not change the variant to variant. Instead, they're all encrypted in the body, the key is different, so malware author never worries about that. If emulator is able to emulate the code and go from function to function, at some point it reaches decryptor. This decryptor decrypts that encrypted data, because malware needs to decrypt the data to use it. So the way signature could be designed is that emulator starts emulating code from the entry point and follow the jump. When it finds the first small snippet of the signature, which for example could be applied to the decryptor of the data, now I have my first part of the signature trigger. And the second part of the signature can say analyze the data section and search for these bytes in data section after the next jump. So because we know we're inside the decryptor and we know that after decryptor is fully executed, the data will be decrypted, right? So we would the emulator would emulate the whole decryptor. Again, we're not executing, we're fully emulating x86 instructions and stack and memory of the executable itself, right? So all the operation applied to the memory of execution, executable emulated. So the decryptor would execute and then it would jump to next code. And that's where our antivirus engine would understand, okay, that's time to apply our second part of the signature to the data section. Those signatures would be very, very well designed, very elegant, because they would rely on emulation of the code structure and dependency between code and the data, or code and the code, and they could bypass some simple obfuscation or indirect jumps, or decrypt some simple string encryption, right? At that time, the decryption would be very simple. Encryption would be of the strings would be very simple. For example, it could be row 13, where the bits just shifted to the left, and then as soon as this emulated, you have strings available in the data section for matching. That would be more elaborate signatures, which would include not just a signature for bytes, but also use emulator both as to pivot around the regions as well as to decrypt encrypted data or emulate indirect calls. And later in this course, I'll show you how such combination will very effectively used to detect and cure polymorphic viruses. Another very important type of antivirus signatures would be signatures with the script embedded. More advanced antivirus products of that time would already have an embedded language. It could be a relatively simple language. You could think about like Lua type of language, and antivirus engine would be able to interpret the language and interpret the scripts written on that language. Of course, however, we wouldn't just run every script on every single file we analyze, because that would be slow and not very efficient. Instead, there would be a combination between signature and script. As always, the antivirus engine would have first signature in the chain, and it would search for that signature. Again, it might be header pivoting, maybe entry point pivoting and disassembling data, maybe import. It would search for that snippet of data, which most likely would be stored as CRC32. And let's say triggers. That first snippet triggers here, and it detects that code it was trying to search for. If that happens, instead of going to the second signature, it would execute the script assigned to that first snippet of the signature. So it would be a hybrid approach between the signatures and the script. And script is written by virus analyst, and what it could do, it could quickly do pretty much whatever it wants. It could already have more extended access to the file. It could even read the whole file from a disk and implement some more advanced logic needed for detection, or even sometimes needed to cure the virus which infected the file. Because remember, we might have a situation when the virus has a touched body here and some malicious jump over here, and the script is the thing which would cure the virus and would remove the virus body and remove the jump to reconstruct the original benign file. And in the next video, we're actually going to talk about how this whole combination of signatures, emulation, scripts were used to detect polymorphic viruses and cure them. That was a lot of information on how antivirus signatures worked in the period of 2000-2005. A lot of these ideas are still used in modern products. Of course, they have been improved a lot over the last 22 years. But I just want to say that even in the beginning of 2000, the antivirus industry already has been pretty advanced in the way those antivirus signatures were implemented. And if you compare those pretty advanced techniques with the file hash-based detection, which unfortunately is still used very often by next generation security products, you kind of start to feel a bit astonished, like why signatures are so hated in anti-malware community. Why is it suddenly a bad thing? The very elegantly written signature could easily detect hundreds of thousands variants of the same malware. Of course, it's difficult to do, and you have to have a good team to support such a complicated engine and develop such signatures, and it cannot be the only thing your antivirus has. But it's surprising that a lot of products nowadays just opt out of having a cloud-based reputation system based on cryptographic hashes instead of trying to apply more traditional ways and actually more advanced ways, if you ask me, on detecting malware. But I don't want to jump too much ahead of myself. We're going to talk about evolution of technology over the years in later videos and later episodes. So stay tuned, and thanks for listening.